potential for growth of energy crop in Iitate village, Fukushima. My name is Toru NAKAJIMA from Tokyo University of Agriculture. So due to the COVID-19 situation, I couldn't travel to the Salt Lake City from Japan. So I have a pre-recorded presentation. If you have a question and comment, I'm happy to answer Q&A sessions. I hope you enjoyed my presentation. So this is my highlight of my presentation. The study has conducted a research project studying the suitability of Fukushima soil for growing miscanthus species for making bioenergy. This could be another alternative for farmers instead of making food in Fukushima. So we found that if all decontaminated farmlands are converted to miscanthus, the field trials show that miscanthus cultivation in Fukushima could produce 256 megaliters per year of bioethanol. And also we found that miscanthus can be the new insight for agriculture production from decontaminated farmland and then high carbon sequestration and miscanthus cultivation that lead fertility of decontaminated farmland can be improved. So introduction of Iitate village. So Iitate village, farmers has been seeking the way to start agriculture production from decontaminated farmland, reconstructing the local communities and economical activities in Fukushima. So as a researcher, I proposed one of the options to growing the miscanthus as an energy crop. So if you look at the globally, the research regarding to renewable energy resources, giant miscanthus has increased significantly. So it has a high potential for biomass energy crop. In addition, miscanthus species has a higher potential for immediate carbon sequestration and also can improve the soil health in Fukushima. So this is my proposal for the Fukushima farmers. So what is the giant miscanthus? Miscanthus is a hybrid of miscanthus sinensis and miscanthus saccharosis. Miscanthus sinensis has a high density of shoot, and miscanthus saccharosis has a strong rhizosphere lasts for a long time. So giant miscanthus has two features of these species. That's why we have a lot of high biomass yield in giant miscanthus. So if you look at the previous research, this is the estimated productivity, water, and nitrogen requirements of the current or potential bioenergy crop. So there's three crop: corn, sugarcane, miscanthus. So if you look at the ethanol yield, the corn has 3,800 liter per hectare. Sugarcane is about 10,000 liter per hectare. The miscanthus also has the same as sugarcane. It's around 10,000 liter per hectare. So if you look at the water resources, the miscanthus has a low water requirement and also nitrogen applications. I thought so this is a good energy crop for the Fukushima. So this photo shows that energy crop field research in Iitate. So we established this site in 2015. The coordinator of this session, Dr. Daniel, so he helped to establish this site. So we worked together. So this is the detail of the research site. We have 5 treatment, giant miscanthus, Akeno. So this is the miscanthus sinensis. This is a high performance species. Corn, sunflower control. So we have 3 replicate and this randomized block design. This research started 2015 and 2018. So I will show you the short time result of this site. So this is the cesium concentration research site. So before we start the experiment, we took a sample from each layers, like 0 to 5, 5 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 60. So, and then we measure the cesium concentration by each year, each depth. So the first layer is less than 200 becquerel per kilogram, so it's not a high concentration to compare to another place. So we thought we can start the experiment. So let's talk about the carbon sequestration under giant miscancers. So this is a different place, but we have four treatment: giant miscancers, Shiozga, this is a high performance of miscancer species, pasture, and then control. So we took a sample and we measured the carbon with isotope carbon 13. Then we evaluate the carbon sequestration rate for each site. So this is the result of carbon sequestration on the giant miscancers. So as you can see that 0 to 5 centimeter, so the giant miscancers can increase the soil organic carbon like 10 megagram per hectare. The second layer is about 5 megagram per hectare. So this happened over 6 years, so which is very short time, but so the soil organic carbon can increase under giant miscancers cultivation. Conclusions. Giant miscancers can be the new insight for agriculture production from decontaminated farmland. Due to the high carbon sequestration and giant miscancers cultivation, the fertility of decontaminated farmland can be improved. More field experiments need to be done in order to develop the bioenergy crop production in Fukushima. So this is a very short presentation. I hope we can discuss in the later. Thank you.